Hey class, this is an example of a bridge hand, a probability bridge hand, and I have to give you a little insight. This problem is probably one of the most missed exam problems and homework problems from this chapter. So I thought, why don't I work it out? Here's the question. What's the probability that a bridge hand of 13 cards would consist of exactly 4 aces and 3 kings? And I'm not a bridge player, but I can picture a hand of 13 and they want 4 aces in that hand and 3 kings. And again, we're looking for probability. So we need to figure out the number of ways we can get that specific hand divided by the total number of ways you can be dealt a hand of 13. So we have requirements for aces, we have requirements for kings, and then there are no requirements for the rest of the hand. For aces, there are 4 in a deck of cards. I'm going to use combination here because I don't care if I draw the heart, ace of ace, ace of heart, ace of diamond, ace of club, ace of spade first. I just need 4 of them. I need them all actually. And then there are 4 kings in a deck, and I'd like to have 3 of those. And again, I don't care which order they're drawn. I just need 3. So as of right now, we have accounted for 7 of the cards that we need. There are 6 more cards that we need, and this problem didn't tell us that they cared what those are. They can be anything. So we've accounted for 4 aces and 4 kings. We've already taken into account how those can be chosen. So we need to take those out of the deck. And there are 52 cards in a deck. And so if we take out 8, there are 44 cards left. And we want to choose 6 of those. So let me back up and say this again. We've accounted for the aces. We've accounted for the kings. So 8 of the cards have already been calculated in the number of ways they can be chosen. There are 52 cards in a deck. And I've accounted for the aces. I've accounted for the kings, which leaves me with 44 cards left that we don't care what's chosen. Again, and the other thing is we have chosen 4 aces and 3 kings, so 7 of the cards are picked. We want a total of 13. 13 minus 7 is 6. So this is the number of ways that we get what we want. For probability, we need to divide that by the total number of ways a bridge hand can be dealt. Well, there are 52 cards in a deck, and we would like to choose a hand of 13. So use your calculator for combination. 1 times 4 times 7059052 divided by, this is a huge number. Use scientific notation, it's so big. One, two, three, 4. And in this case, you'd really have to look at MyLabs Plus and find out how they want you to answer that. There you go. So a pretty low probability that you're going to get all 4 aces and 3 kings and a bridge hand. I would not put your money on that.